Today we're going to be talking to you about the Geotech module in iSight Studio. Your hosts are Scott Sheely and Desiree Wentland. Scott is the iSight Technical Services Manager in Maptek's Denver office. He's an expert with the iSight 3D laser scanning technology, the scanner as well as the software. Desiree is the geologist and Vulcan Technical Services Manager at Maptek. Her areas of expertise include Maptek's geotechnical and geophysics tools, as well as geostatistics. Today's webinar will conclude with a question and answer session, so please feel free to write in your questions in the panel on the right. Scott will get us started with some background on the iSight tools.
Thanks, Stu. So today we're going to teach you mainly about the iSight Geotechnical module. But before we get into the Geotech module, I'm going to get into a quick overview on some of the iSight modeling techniques and our field acquisition side. So starting first things first, what you need in the field is a iSight 8800 laser scanner and about 20 minutes time. The iSight 8800 works very similarly to a standard total station. You can use two-point georeferencing, much like a total station, where you occupy a known point, backside another known point, and you can georeference the scans that way. There's no need for targets on the walls or any other surveying to be done. A GPS system can be mounted right to the thread on top of the scanner if you have access to a GPS. You use a high-resolution optical scope for backsighting, so the backsight can be a couple miles away or a couple hundred feet away. It doesn't really matter. The software looks a whole lot like a total station as well. So you give the scanner location a point name, and you give the backsight a point name. You put a scanner height in to get the elevation right. You check your light settings and you go. As you go to the next menu on the scanner, it takes a 360-degree image that you can use for drawing a box around what you really are interested in. You don't need to do a 360-degree scan if you don't want to. You can just highlight the area of interest and select your resolution and hit go. So your resolution settings are right here on the right. You can see we have 5 different resolutions ranging from a 1 to a 16. Depending on the amount of detail you want in that area is kind of the resolution you'll pick. A 16 resolution at 300 feet away, points are going to be about 3/4 of an inch apart. So if you multiply that out to 900 feet away, you're talking 2 1/4 inches apart. So you can see it's very detailed on the laser side of it. It's also taken a high resolution image as you scan, so it's about a 70 megapixel 360 degree image, and that's all acquired during the acquisition. There's a little bit of a diagram on kind of the point spacing and kind of more of a visual of those spacings. Once you have your scan, then it's time to go into the iSight Studio software. You can see here there's a scan that's in a more of a 360 view or 3D view. The scan takes that photographic image as well and colors the points with that, so you can see the color trends in your data as well. Once you have the point cloud in, the point cloud will tell you a lot, but really to run the Geotech module efficiently, you're going to want to make triangulated surfaces out of the data. And iSight has some very unique ways of modeling the data. So we model all the undercut and overhang in the data. So you can see on the left there's a 2D triangulation. It's more of your typical CAD type triangulating algorithms where your undercut in your face doesn't show up because it's from a top-down projection. On the right, you can see more of a 3D projection from the orientation of the scanner, and you can see the undercut and overhang is modeled quite well. Once you have the model's made. You can do each individual scan, or we have a fusion surface technique which allows you to model multiple scan locations into one model. So you can see the problem with the scan is you got one image. As you rotate it in 3D, you'll see the shadow zones that the scanner just couldn't see. So you can go around to that side of the wall and do another scan and then merge those together, and it creates more of a 3D shot of the face. So you're seeing all the different joint planes and the 3 dimensions of them. So with that, I'm going to take it now into the live software tools. And for this, we're going to be working live right in the iSight Studio software. And you can see the very easy to use interface here. You got all your different models and scans that you've done on the left, and we're going to drag those out into the view, and that's going to load that scan instantly. And you can see this is the 3D point of that scan, and this is only one scan. And so as you zoom in, you can see the point pixelation come out, but those are all 3D XYZ points. You can drape the high-res imagery over this data just by selecting a group of points or the whole scan, and then you can drape the high-res image over that. And that drapes that 70 megapixel image onto the scan. So now if you want to do some quick geotech, if you want to get a quick strike and dip of a joint set, you can simply draw a box around that joint, right click, query, dip and strike. That instantly tells you kind of what that orientation is. You can keep selecting multiples and it'll keep selecting or keep telling you what your strikes and dips are. So those are quick ways to kind of get the information. If you're looking for one or two joint sets, really easy to do. You can also export those out as a text file just by clicking the export button, and it will export a text file that's the orientation, centroid, and strike and dip direction. So that's an easy way to get the data out. For more advanced processing, what we like to do is actually make 3D planes out of these surfaces. To do that, I'm going to highlight a group of points. I'm going to create a fitted plane. And what that does is creates a CAD object with that orientation. And so you can go around and select all the different orientations. And it keeps creating these planes. So for this data set, I've actually modeled a bunch of the planes already. You can see those as I load them into 3D space. And what we're going to do now is I'm going to hand it over to Desiree, who's going to talk a little bit more about some of the more advanced geotech tools we have to offer. So.
Thank you, Scott. Now that Scott has modeled a bunch of these planes, we can load them easily and analyze them using orientation rose diagrams, equal area, or equal angle stereo nets. First, we'll load up the rose diagram and load the data by strike into a rose diagram with 20 divisions. Rose diagrams allow you to easily load strike and dip direction information to easily see orientation populations. According to the rose diagram, the dominant structural trend in this data set is almost due north-south. Another tool available in the Geotechnical toolbox is a StereoNet contour option. Similar to a rose diagram, the contour option quickly allows you to see dominant structural trends. Let's load that same structural data into the StereoNet for contouring. To load the data into a StereoNet, we will use Geotechnical StereoNet. The StereoNet panel gives us the option to load data from the selected planes in your view window or from an imported ASCII file. You also have the option to output your loaded results to a text file, which can then be imported and used in other software packages such as Vulkan. Since we are performing population analysis on the structure, we will load the selected data into an equal area net. You will notice that the data loaded into the StereoNet is points. These points represent poles to the structural plane. We can make the points larger or smaller by selecting the minus or plus keys on your keyboard. Plotting data as poles allows you to quickly view large data sets and perform slope stability analysis. Now that our data is plotted, we can begin to contour the data. In the contour panel, we can specify the major or minor contours colors as well as the number of contour intervals. We will use red and blue for the major and minor interval and create a contour with a plot of 5 intervals. Now that the contours are loaded, we can see that we have a graph with 5 contour lines colored in spectrum between red and blue. Looking at the results, we can see the dominant structural trend that runs almost north-south with a dip around 80 to 85 degrees. This is consistent with the strike results we obtained from our orientation rose diagram. We will now remove the contoured data and reload the structural data into a StereoNet for stability analysis. iSight Studio has 3 main tools for slope stability analysis: daylight window analysis, toppling, and friction cone. These tools can be found under the Geotechnical Great Circle menu. As soon as the panel opens, a great circle is plotted on the StereoNet. You can enter arbitrary planes such as proposed pit slopes directly into the StereoNet by keying in data directly or using either slider bars. This makes it easy to analyze different operational or design scenarios. For this data set, we will be using a bench face strike orientation of 201 and a dip of 80 degrees. Now let's start playing with the stability analysis tools. Any of these stability tools can be plotted in combination with each other or one at a time. The first option we will look at is the friction cone. Friction cone analysis allows you to determine structures that have a propensity to allow a block of rock to slide. To use the friction cone option, you will first need to know the friction angle for the type of rock you are dealing with. The friction angle is related to fracture mechanics, so a typical default angle for most rock types is usually between 30 and 35 degrees. We have specified an angle of 30 for this data. A circle with a radius of 30 is plotted around the center of the equal area net, since gravity is a downward force. Any structural pole that plots outside the friction cone has the potential to slide. The next option we will look at is the toppling envelope. Toppling occurs when a load of rock is inclined steeply into the pit wall and fails from the crest or top of the rock formation. To perform toppling analysis, we will need to know the angle of inclination in addition to our bench face orientation and friction angle. To determine the angle of inclination, we will calculate the angle between the structures of interest and the vertical plane. For example, we have a fracture set that dips away from the pit wall at 85 degrees. Thus, the angle of inclination will be 15. You will notice that the toppling envelope is displayed as a polygonal area on the StereoNet. Any structure that falls within the envelope has the potential to fail. Finally, we will look at the daylight window option. The daylight window analysis highlights structures that may protrude or daylight out away from the pit wall and fail. Based on the results in this plot, structures that have a strike orientation between 30 and 160 and a dip orientation between 30 and 80 within the daylight envelope may be problematic. Let's go back to the view window and color the scan based on the strike and dip range to highlight structures of interest in the daylight window we analyzed. We will enter a strike range of 30 to 160 and a dip range of 30 to 80. This will color the resulting scan using a strike spectrum. If we look at the bench we have been analyzing, we can easily see the highlighted structures that may need to be monitored. Now Scott will show us how to analyze for surface change.
So with that, I'm going to hop back into the PowerPoint real quick and talk a little bit about the surface change tools we have for monitoring. All right, so once you have the wall mapped and you're interested in monitoring the wall for surface change, iSight has several tools that will color and highlight the area of change. So you see here, this is a canyon wall. This was scanned a year apart, and you can notice right away the orange spot in the corner that is changed, and that the software is actually coloring the one scan versus the other, and you can put a color spectrum, whether it's blue or orange, on the area of change. As you zoom in, you can see the orange block has fallen and deposited some material, and that's fill. So you got your cut and fill. As you cut a cross section with that, you can see you've got a 15-foot block of data that has fallen off that wall. Those are big scale movements. Everyone has a question of how much change can be detected with the laser scanner. I don't think we can fully tell you exactly how much change. It really depends on the amount of movement and how much of your wall is affected. This is a test we have set up where we've moved a few targets anywhere from a couple millimeters to a few centimeters. A couple millimeters was a little hard to detect, but we could see about a centimeter of movement on this test. With that, I'll hop right into the software and show you this wall live. You can see we have the base scan. And you got your first round of movements. And just right there you can see the coloring of the green sticking out is more of a, it's been pushed out. And then we have our second scan that was pushed out a little bit more. With that, we can actually analyze that a little bit further by using our Geotech Analyze Surface Change. The Analyze Surface Change is a pretty simple option. You can load all three surfaces at once. You can analyze that. You can go in and you can color the amount of change. For this, we're going to measure it from the base, which is the first scan that was done. You can do it to the previous measurement and kind of see one scan at a time how much movement. You can also measure it on velocity, whether it's changing 2 inches per week or 4 inches per week. For this, we're going to set our band interval at 1 inch. And we're only going to color the things that are within a half a foot. So you can also create the legend. I'm going to drag the surface we've colored, which is the last one out. And you can see the coloring, you can see the wedges we put in the rock and the different changes that have happened. You can also save that as a text file so you see what points were actually affected just by dragging those out. And those were the points that are moved more than an inch. And you can see those points that are affected. With that, that gives us a little bit of an overview, or a very good overview of our geotech tools. I'm going to hand it over to Stu for some question and answers.
Thanks, Scott. So we've got a few questions that have come in. The first one being, how can we input rock properties?
Rock properties at this moment cannot be inputted into iSight. That's something you'd want to use Vulkan, the Geotech module in Vulkan for. We can easily export all our measurements as a text file and import those into Vulkan. So for a more complete geotechnical package, you'd probably want to use Vulkan.
Okay. For slope stability for different failure, is it possible to analyze with it or not? Not sure I understand that question fully. So slope stability for different failure, is it possible to analyze with it?
Depending on the failure is really, I think, the rock type and the rock material. Some rocks are going to move a couple millimeters before they're on the pit bottom, and some are going to move a couple feet before they actually fail completely. And I would say for your rock types that are much more of a smaller movement, you're going to want a more accurate means. You know, if it's going to move a couple millimeters and then fail, we're not going to be able to detect a couple millimeters, but a couple centimeters we can easily detect that. So if that's what that question means, I think that's what it is.
Okay. Is it possible to assign different joint sets a different color, like in Vulkan?
There is a way to do that with the strike and dip coloring. So I can easily pull these planes that we've made and I'm going to color these by strike and dip. So I can either color them by strike or by dip, and when I hit OK there, it'll color all the orange ones that are the same strike, the same color, and you can see the legend of, oh, that's the surface change. The legend of what your colors actually mean. So that is possible to color those planes by strike and dip.
Okay. What is the best resolution to select for scanning?
That's a very tricky question. It really matters how far away from the face you are and how much time you've got on your hands. Your average 16 resolution, if you're shooting a couple thousand feet away, is going to take you about 40 minutes to scan. Where the average geotech scan, we're normally a few hundred feet away and doing a resolution 8, which averages about 20 minutes. So it really depends on how close you can get to your area of interest.
So I think we got one more question here for today. Can you use this software with any other scanning system, or does it have to be with the iSight scanner?
You can use it with absolutely any scanner on the market. The advantage you have with the iSight 8800 is the photo that's built into the scanner. So we've got the camera, or the color, kind of automatically taken at the same time. The other scanners on the market, sometimes you can get external cameras that can't necessarily be imported into the studio. You can do some manual mapping of those photos onto the data, but it's a long, tedious process.
Thanks, Scott. I think that's all we've got time for today. So on behalf of Scott and Desiree, I want to thank you all for attending today's webinar. We look forward to seeing you at the next one coming up on September 20th for stockpile volume calculations. If you have any additional questions, you can always visit maptek.com and register for other upcoming webinars or learn more about our products. So on behalf of the Maptek team, thanks again, and we'll see you next time.